Hello everyone. Welcome to my channel. So we'll try this problem. So here you can say that this is also one of the contest problems. So here they have asked to prove that the nth least prime is less than 2 power 2 power n, right? So usually when we see these type of questions, so usually our intention or intent is to try to prove it with mathematical induction. So this one also we will try to prove using mathematical induction. So let us see the base case that when n equal to 1, so that is the first prime. So then you see that it is 2, right? So that is, you can say p1. So let us say that p1 p2 up to so on be the list of primes. So then on the other side you have 2 power 2 power 1, right? So that is 4. So indeed we have 2 less than 4. So implies this base case is true, right? Right. So next we'll assume that the result is true for all n. So induction hypothesis. So induction hypothesis that the result is true for all n less than equal to k. So yes, so that is up to kth prime we have this result true. So now for n equal to k plus 1, let us see what happens. Right, so k plus 1 to show that so p k plus 1, right? So since we are taking this as a list of the primes, so we have to show that this is less than 2 power k plus 1. So this one you have to show. Okay. So but we know the results for pi's. So each pi is less than 2 power I for all 1 less than equal to k. Sorry, 1 less than equal to I less than equal to k. So this is true. So this we can highlight. So this actually we know, right? So next what we can have is, so let us consider this number capital N to be the product of all primes up to k. So p1 p2 up to pk, then plus 1. So usually this technique is used to prove that some type of primes are infinite, right? If you remember, if you have gone through or faced any such proofs, then you will see that this is a usual technique to take n like this and prove that certain maybe 2 or 3 n minus 1 or something, that type of primes are infinite. So we'll use that n. So here what is the usual logic is, so pi does not divide n for all 1 less than equal to I less than equal to k. So this is by construction of n, right? You can see if you go through this number, so p1 does not divide this because p1 divides the first part, but plus 1 we have. So similarly for any I, pi does not divide n because we have this formation. So here pi will divide this part, but pi will not divide this part. So that is the thing. So this is a number which is greater than each of the primes p1 p2 up to pk, right? But here you can say that this is a composite. So this is so it is at least, so pk plus 1 is less than equal to n, right? So this is true because none of the pi's is divisible. But if it is prime, then it is at least pk plus 1. But if it is higher, then it should contain pk plus 1. Contain in the sense it is greater than pk plus 1 because it is divide. Pk plus 1 will divide this n, right? At least pk plus 1 or more prime or higher prime will divide n because n will have a prime factorization, right? So pk plus 1 is less than equal to n, so that is true. So this will imply pk plus 1 is less than equal to n. But now let us try to use the induction hypothesis. So this is, we can write in a product form. So I equal to 1 to k pi plus 1, right? This is n. But this is strictly less than product I equal to 1 to k. Pi is less than 2 power I, right? Plus 1. So but 2 power, so this thing is in the power, right? So this product, once it goes inside, it will become summation, right? So this is nothing but 2 power summation I equal to 1 to k 2 power I, plus 1 is outside, so that is fine. So now you can check that it is nothing but 2 power k plus 1 minus 2. So this I am not doing, so this part I think you can check already. So I am saying about this. So this part if we bring down here, so then summation actually I equal to 1 to k 2 power I is nothing but 2 plus 2 square. So this is a finite GP, you can usually find this 2 power k. So if you take 2 common, then we have 1 plus 2 up to 2 power k minus 1, and this is nothing but 2 times 2 power k minus 1 divided by 2 minus 1. So that is 2 power k plus 1 minus 2, right? So once this is done, but this you can easily say that is less than 2 power k plus 1, because we have minus 2 here, so it's divided by 2, and plus 1 will not make any much difference because we are exponentially increasing the power of 2. So we have shown that pk plus 1 is less than, strictly less than 2 power k plus 1, so hence the result is true. For all n by induction. Okay, so I hope you enjoyed this solution. So you can again stop and rewind and go through the solution once again, and also subscribe to my channel so that it motivates me to create more such solutions. Okay, bye for now.